The crankshaft position sensor, or CPS, is a vital component in your vehicle's engine. It monitors the crankshaft's rotational speed and position, generating signals that the engine control unit, or ECU, uses to synchronize ignition timing and fuel injection. This sensor typically uses magnetic or Hall effect technology to detect changes in the crankshaft's position as it rotates. The CPS works by detecting the position of the crankshaft, often through a reluctor ring or toothed wheel attached to it. As the crankshaft spins, the sensor sends precise timing data to the ECU, ensuring optimal engine performance. Without a properly functioning CPS, the engine cannot operate efficiently. It may not start at all, or run poorly with issues like misfires and reduced power. This makes the sensor essential for engine operation. The CPS is typically located near the crankshaft pulley at the front or bottom of the engine, where it can monitor the crankshaft's rotation directly. Common symptoms of a failing crankshaft position sensor include engine cranks but won't start, rough idle or stalling, especially at low speeds. The check engine light comes on, often with codes P335 or P0336. Reduced fuel efficiency and power loss are also indicators. Misfires or backfiring can occur. These issues might worsen in cold weather or under load. If you notice these, the CPS could be the culprit. CPS failures stem from several factors. Long-term wear and tear from vibration and heat degrade the sensor and its wiring. Electrical issues, like corroded connectors or short circuits, can disrupt the signal. Contamination from oil leaks or metal shavings is another cause. Manufacturing defects, although rare, do happen, especially with aftermarket parts. Extreme temperatures and moisture also contribute to failure. Begin by visually inspecting the CPS. First, disconnect the battery and ensure the engine is cool. Check the sensor's wiring for damage or looseness. Look for signs of oil contamination near the sensor. Addressing these obvious issues early can save time. Connect an OBD2 scanner to your vehicle to diagnose the crankshaft position sensor. Read any stored trouble codes, especially P0335 or P0336, which indicate crankshaft position sensor problems. Clear the codes and monitor if they reappear after starting the engine. This provides crucial diagnostic information. Begin by disconnecting the sensor plug to safely access the electrical connections. For inductive sensors, use a multimeter to measure resistance. The typical range is 200 to 1000 ohms, but always consult your vehicle's service manual for the exact specifications. For Hall effect sensors, turn the key to the on position without starting the engine and measure the voltage. It should read between 5 and 12 volts. If the readings fall outside these ranges or are inconsistent, the sensor is likely faulty and needs replacement. Compare your measurements against expected values, and if in doubt, test the circuit continuity as shown in this diagram. Step 4 involves carefully inspecting the crankshaft pulley and its reluctor wheel, also called the tone ring. This is the toothed wheel that the crankshaft position sensor reads to determine engine position. Look closely for any signs of damage that could interfere with the sensor's signal. Start by examining the pulley for cracks. These can develop from stress or impact and may not be visible without close inspection. Even small cracks can cause the pulley to wobble, disrupting the sensor readings. Check for bends or warping in the pulley. This can happen from overheating or physical damage and will affect how evenly the reluctor wheel rotates past the sensor. Inspect the teeth on the reluctor wheel carefully. Each tooth creates a signal pulse as it passes the sensor. Look for missing teeth, which will cause gaps in the signal and lead to erratic sensor readings or engine misfires. If you find any damage, cracks, bends, or missing teeth, the pulley must be repaired or replaced to restore proper sensor function. Always use the correct replacement part for your vehicle make and model. If the crankshaft position sensor is faulty, replace it with a new OEM or high-quality aftermarket part. Torque the sensor to the manufacturer's specifications, usually 10 to 15 foot-pounds. After replacement, perform a crankshaft relearn procedure using a scan tool to recalibrate the ECU. Refer to your vehicle's service manual for specific instructions. Test drive the vehicle to ensure the issue is resolved. If problems persist, investigate related components like the camshaft sensor or ECU.